In this video, we are going to talk about theorems concerning circles. First, let's have a quick look about the parts of circles. The first part here, this is called the diameter of the circle. And this one is radius of the circle. This is the circumference of the circle. And this part is sector. And the sector is held by two radii and a minor arc. This segment outside the circle and touches it in one point, this is called tangent to the circle. And this segment inside the circle, which is not a diameter, is called a chord. And this part is a minor segment. Circle theorems are laws that apply to both angles and lengths when circles are involved. We will deal with them in groups. The first group is non-circle theorems. These are not circle theorems, but are useful in questions involving circle theorems. The first one here, angles in a quadrilateral add up to 360. So, for example, if this angle is 50 and these two angles are 90, so the remaining angle will be 360 minus 50 plus 90 plus 90. This will give us 130 degrees. Another theorem, that base angles of an isosceles triangle are equal. Remember this step. Remember the wording in the black boxes, because you are often required to justify in words a particular angle in an exam. The first one is angle between radius and tangent is always 90 degrees. So radius and tangent are always perpendicular. Another theorem, angle in semicircle is 90 degrees. A semicircle is half a circle, and half a circle means that it is cut by the diameter. If we draw a triangle with the diameter as a base or the hypotenuse, the angle up here will be the 90 degrees. So always the hypotenuse of the triangle must be the diameter, and this angle in the semicircle is 90 degrees. Angles in same segment are equal. These two angles are equal because they both have the same two end points. Another theorem, that angle at center is twice the angle at the circumference. Both here, the angle at the center and the angle at the circumference have the same two end points. Angle at the center is twice or double the angle at the circumference. Opposite angles of cyclic quadrilateral add up to 180 degrees. So if we have a quadrilateral that's inscribed inside a circle, the two angles opposite to each other make 180 degrees. So each two opposite angles in the quadrilateral add to 180 degrees. Lengths of the tangents from a point to the circle are equal. So if we have two tangents to the circle that meet or intersect at a point here, the length from this point to the circle and from this point to the circle on the other side, both are equal. Radius is of constant length. So when you have multiple radii, put a mark on each of them to remind yourself that they are the same length. This result is that any triangle with one vertex at the center and the other two on the circumference must be isosceles. Identify which circle theorems you could use to solve each question. So let's have a look at this question. We need to find the center or the central angle here. So what do you think, which theorems are we going to use? So we're going to use opposite angles of cyclic quadrilateral add to 180 degrees. So this means that if this is 100 degrees, the opposite angle in the quadrilateral inscribed in the circle will be 80 degrees. The other theorem we're going to use is the angle at center is twice angle at circumference. So this means that this will be double the angle at the circumference, so this will be 160 degrees. Second question, we need to find this angle. So let's think together which theorems we can use to find this angle. We can use angles in same segment are equal. Yes, because this segment at this angle and this angle, both of them hold the same segment, so they are equal. Now we need to find this central angle. Which theorem are we going to use? We are going to use angle between tangent and radius is 90 degrees. So first here we have this is 90 and this is 90. And in this quadrilateral, we have three angles that are known to us. Only this one is missing. So we're going to use the theorem that angles of quadrilateral add to 360. So we're going to subtract 360 minus 65 and 90 and 90. So the answer will be 115 degrees. This one, we need to find here this angle. So we're going to use angle in semicircle is 90 degrees. So because this is a semicircle, because BC is a diameter, so this means that the angle here above, which is BAC, equals 90 degrees. We also know that BO and AO are radii of the circle. So this means that this angle OBA is equal to OAB. Both of them are 20 degrees. So what remains here is 70 degrees. And because OA and OC are radii, this means that angle OCA is equal to angle OAC in this isosceles triangle, so this will be also 70 degrees. In this example, we need to find this angle. So we're going to use angles in same segment are equal, so this angle and this angle will be equal. But before this, how do we know what is the angle QPR? From base angles of isosceles triangle are equal, because this is isosceles triangle, so this means that this angle is equal to this angle. QPR is equal to angle QRP, and both of them will be found by subtracting 180 degrees minus 116 degrees and then divide by 2, and then we will find the same angle here in QSR. Identify which circle theorems you could use to solve this question. So we're going to use angle between tangent and radius is 90 degrees. So angle OCS is 90 degrees. This means that angle OCA is 90 minus 56. Also, we're going to use that angle at center is twice angle at circumference. So if this is 130, this means that CAB is 130 divided by 2, that is 65 degrees. Also, angles of a quadrilateral add to 360. But what remains here is I have the angle around the center O is 360. So we're going to subtract 360 minus 130 to find this angle. And then we're going to find angle OBA, which is the missing one, by subtracting it from 360 to become 31 degrees. This one is probably the hardest to remember and a particular favorite in the intermediate senior math challenges. If we have a tangent and a chord, then the angle between the tangent and a chord is equal to the angle in the alternate segment. The alternate segment is called like that because it's the segment on the other side of the chord. Now, check your understanding.